السلام عليكم أصدقاء الطلاب. Welcome to Chemistry Online with Mr. Ahmed Sulaiman. Today we are going to study chapter 4, atomic structure. The first lesson of this chapter is defining the atom. First, what's meant by atomic structure? You studied the structure of the atom before. Recall what you studied before about the atom. You know, the matter has three states: solid, liquid, or gas. If you have piece of solid, like piece of iron, piece of copper, some liquid, like some water, some gas, like balloon containing kind of gas, whether oxygen gas as element or carbon dioxide gas as a compound, whatever. You have any of these substances or any of them composed of atoms. Look, if solid made of atoms like this, okay, and if it's liquid has molecules and each molecule has atoms, okay. If it's a gas, whether oxygen, carbon dioxide, or any kind of gas, molecules, and these molecules composed of atoms as well. It means any kind of matter has something called atom. Atom is the basic unit of any substance. You studied the structure of the atom before. The atom cannot be seen, as you know, it's very tiny. But from some experiments and observation of these experiments, they found or they built some observations, or they put theories or models of the structure of the atom. The models of the structure of the atom built before says that the atom composed of nucleus containing protons, carry positive charge, neutrons, neutral, and surrounded by levels of energy, has electrons carry negative charge. The levels may be 1, 2, 3, up to 7. This is the structure of the atom that we studied before. We will start to define the atom. First, we need to define the atom. What is the atom? The atom is something very tiny, very small. You cannot see it by your naked eyes. From the early models of the atom, they put a concept by the scientists, but before the scientists, there were philosophers. Philosophers put some ideas about something very small inside the matter, which is the atom. One of the famous scientists called Democritus. Then, after many philosophers, the scientists came, and one of the famous scientists who built the idea or the theory of model of atom called Dalton. What did they say? Democritus said that there is something very small inside the matter, which is the atom, cannot be divided, or he said indivisible. Indivisible means cannot be divided, and indestructible, cannot be broken. This is Democritus. After that, Dalton came as scientist. Look, you have to know the difference between the philosophers and the scientists. Philosophers built their ideas by observations, not by experiments. But scientists came and built their ideas or theories by using experiments, by testing them, testing what they need. What is meant by atom from all of that? Atom is the smallest particle of an element, the smallest thing in the element, okay, that retains identity in the chemical reaction. If you divide the substance into smaller and smaller and smaller to find the atom has the same properties of the whole substance of the same element. This is the meaning of retains its identity in the chemical reaction. It has the same properties. As I said, philosophers put their ideas based on the observation, but scientists observed these things, but they make like experiments to make sure it's true or not, or like this, and put their ideas according to this. Democritus, one of the philosophers, one of the famous philosophers, he suggested the existence of atom, okay, and he said that the atom cannot be divided or indestructible and indivisible. The idea of Democritus still for a long time, up to the scientist came and Dalton, one of these scientists, and put this theory which called Dalton's atomic theory. This theory composed of some points. Dalton's atomic theory. He collected all ideas of Democritus that he agreed with them and other ideas in this theory. Dalton studied the ratio of the elements combining in a chemical reaction and put a result, yani he used a chemical reaction like A plus B yields C, like this. This is a chemical reaction. From the reaction he observed many things and he tested them and found some points, put them in a theory called Dalton's atomic theory. What are the points of this theory? The first point is all elements are composed of tiny indivisible particles called atoms. He agreed with Democritus by this point, you know. If you have some atoms of an element A, the atoms here are indivisible. You cannot divide any of them, okay? And each one of these called the atom. He said that. Number two, he said atoms of the same elements are identical. Look, if you have an element A, and this is the atoms of this element, are they identical? Yes, they are identical. Not similar. Don't say similar, but identical. In chemistry, similar means the same, but not exactly. But if you want to say exactly the same, you have to use this word identical. So they are identical means exactly the same. The atoms are exactly the same if they are in one element, element A. Look at element B. The atoms are exactly the same. Yes, very good. Okay? Identical. But elements are different from those of any other elements. Look, this atom of this element different from this atom of this element. The atoms of different elements are different. Number three, atoms of different elements can physically mix together or can chemically combine in simple ratio form compound. How come? If you have atoms of an element and atoms of other element, okay, you can mix them together, yes, but if you mix them together physically, you are making mixture. Yes, we said that before. And you can add them, but don't say add, but say combine them together, okay, with the special or specific ratio, whole number ratio. At this moment you can do that. Yes, you can do that to make something called compound. So the verb mix to produce mixture, the verb combine to produce compound. You can form mixture from some elements, some atoms of elements. You can make a compound from combining of some atoms of some elements. That's what he said in number three. Number 4 in the theory, he said that chemical reaction occurs when the atoms are separated, joined, or even rearranged in different combinations. This is the first part. Second part, atoms of one element are never changed into atoms of another element, even they are in the chemical reaction. Let's explain the first part here. When you have atoms in a reaction, look, if you have reaction A plus B yields AB, this atom A and this atom B elements produces a compound which is AB. These reactants and these products. The products have atoms of the reactants, the same, A and B. To form this compound, you did something. Imagine this A composed of atoms like this, and this B composed of atoms like this, مثلا. To form AB, this atom may be join this atom to form this compound like this. Maybe. To join this with this is separated, and this is separated from other atoms. Yes. So, separated or joined. Sometimes the reaction, the atoms are rearrangement. That means this atom come like this atom come like this, and form a new compound in the product. That means rearrangement of atoms. Okay? Like the example, I'll give you example. If you have AB plus CD yields A D plus CB. Look, A rearranged with D to form AD, and C rearranged with B to form CB. So rearrangement happens here. It means to make the reaction, maybe separated the atoms, maybe join the atoms, maybe rearranged the atoms, okay, in different combination. It happens in the reaction. Second part, if you have atom of one element, they are never changed into another atoms or another elements in the reaction. Look back to this reaction I did. A, B plus C, D forms A, exactly A, B, exactly B, C here, and D here. Nothing new here. You cannot change the atoms into new atoms. Maybe rearranged, joined, separated, yes, but no new atoms in the reaction. You cannot say A, B plus C, D yields A, K plus L, F. New elements. How come? It doesn't happen like this. This is a point he mentioned in this theory number 4. If you want to imagine the size of the atom, we have instrument used to observe that. This device called scanning tunneling microscope, or sometimes it's called it scanning electron microscope. First, if you want to find out the properties of the atom, imagine this is a mercury, an element, mercury. If you have drop of mercury, divide it into smaller, it makes smaller drops. Divide it into smaller, makes smaller drops, then smaller drops, and so on. Each of these drops has the same properties of the previous drop, so no change in the properties. Chemical properties the same, even you divide the drops, but the smallest drop or droplet has the same properties and also many atoms. You cannot find only one atom by this dividing. Also, if you grind a copper coin, if you have a coin of copper and you grind it into powder, okay, the substance, which in the form of dust, has the same properties of the coin, because the same element, okay, would have the same properties of copper, the same element, copper, okay, even you divide them into smaller pieces, okay. Type. Atoms are very small. Let's imagine that if you have a pure copper coin like this, copper coin penny, okay, it has atoms. How many atoms it has in this penny? About 2.4 times 10 power 22 atoms. Look, large number. And if you imagine that 2.4, okay, and in front of this about 22 zeros, you can imagine that, okay, large number, okay. The people on the earth, or the population on earth, are 7 times 10 power 9 only. Look, the people on earth, and this number is very large, larger than this number, 2.4 times 10 22 10 power 22. It's very large. Imagine again by another method. If you have atoms of copper and you put 100 million atoms side by side like this in one line up, 100 million copper atoms side by side in one line them up, you will find that 100 million atoms form 1 centimeter only, just 1 centimeter long. You can imagine 100 million atoms form 1 centimeter. It means the atom is very, very, very small. And they make a beam of electron and focus them on the sample of atoms, what we need to see, and they could see or magnify this, and they saw the atoms. By seeing the atoms, you can study the behavior of these atoms, whether these atoms in your body, in something non-living, or anything. You can create devices, you can make circuits, you can make computer chips to be able to see that. They made that, and they make a device from individual atoms called nano cars. Why? Because they made of atoms, and it's very similar to the car, has like wheels here, and it moves like this. So they call this technology, or this device, nano cars. These nano cars can be measured by scale called the nanoscale or atomic scale, whether this or that. This technology. By this technology, we are able to study many things, the behavior of atoms, of many things, to be benefit in many fields, like medicine, like communications, like solar energy, space exploration, many fields we can use this technology in it. How was Democritus' idea different from Dalton? As you know, Democritus' idea didn't explain the chemical behavior, because he built his speech or idea about the atom from the observations, and he wasn't a scientific theory. Why? Because he didn't do experiment. He didn't do experiment to support his idea. Okay, but Dalton used experiment. Okay, Dalton transformed Democritus' idea into theory, because he used experimental support. Okay, by explaining this behavior of the atom. This is lesson 1. I hope to understand everything. Thank you, Shabab.